Okay, section 11.4, solving equations with rational expressions. Some things to remember, and this might be a new one. Rational expression is actually a phrase that just means fraction. So when you see the title of chapter 11.4, solving equations with rational expressions, that just means you're solving equations with fractions. Some of those fractions might just be, there might just be two fractions, you might see here that a proportion is two fractions with an equal sign in between them. So basically a fraction equal to a fraction. We can solve a proportion by cross multiplying. And we'll look at some examples of that in just a little bit. Also, you're going to be asked to find restrictions. And a restriction is any value of x that would make the denominator 0. Shortcut tip for some of the problems that we'll look at that have more than two fractions. We can simplify equations with fractions if we take each numerator times the common denominator for the entire equation. First up, we'll look at a problem about proportions. On a map, each inch represents 4 miles. What is the distance represented by 6 inch? So it wants us to set up a proportion for the word problem for step 1. So one thing you want to look at from this first sentence, on a map, each inch represents 4 miles. So in other words, 1 inch, each inch represents 4 miles. So 1 inch represents 4 miles. We want to start off setting up the proportion like that. On top, the 1 represented inches and the 4 represented miles. And what we're going to do on the other side of the equal sign is, it says, what is the distance represented by 6 inches? So 6 inches, we are going to write that on top since we're putting inches on top. And miles, we don't know how many miles. That's what we're asked. What is the distance? And we're going to use x to represent the miles for 6 inches. Okay, so that'll be the first part. You'll actually just plug those numbers in. 1 on top, 4 on bottom, 6 on top, and x on bottom. And then to solve the proportion, we actually just cross multiply. So you've got your 1 over 4 equal to 6 over x. This is what's called a proportion. We can cross multiply in this case. 1 times x equals 4 times 6. Put that in parentheses because we're multiplying. Okay, so in other words, 1x is x, and 4 times 6 is 24. And that would be miles. Okay, next up, got basically the same thing. At a new power plant, 2 out of 50 computers produced are defective. If the daily production is 3,800 computers, how many are defective? Step 1 of 2, set up a proportion for the word problem. Use x as the unknown variable. So we're told that 2 out of 50 computers are defective. So 2 out of 50. And the 2 actually represents the defective computers, and 50 represents the total. So 2 out of the total are defective. And then next it says, if the daily production is 3,800 computers, how many are defective? So the thing that we're looking for, the defective number, is what we don't know. And the total produced in this instance is 3,800. So we've got the total on bottom, defective on top. And next up, we're just going to set it up and solve it. 2 over 50 equals x over 3,800. And anytime you've got one fraction equal to another fraction, we can cross multiply. So 2 times 3,800 is equal to 50 times x. 2 times 3,800 is 7,600 equals 50x. Then we want to get x by itself by dividing. And we have to divide both sides by 50, and we get x equals 152. Okay, so that's the number of computers that are defective out of the 3,800. Next up, consider the following equation. Negative 3 over 3 equals 10 over x. And it says state any restriction on the variable if they exist. And one thing I want to make sure to stress here that if a variable is in the denominator, and denominator is on the bottom, so if there's a variable in the denominator, there is a restriction. And on the flip side, if there's no variable in the denominator, there's no restriction. In this case, if you look here, we do have a variable in the denominator, so there will be a restriction. So we want to make sure that none of these denominators are 0. If we've got a denominator of 0, then we've got an undefined fraction. For example, 5 over 0 is undefined. And we're hoping to avoid a situation where we've got a 0 on the bottom. In this case here, if we look at this fraction that has the x on the bottom, we're going to ask ourselves what value, if we put it in there, would make that undefined. Well, if x is equal to 0, 10 over 0, then this fraction is undefined. So our restriction is 0. X cannot be 0, because if it is, then our fraction is undefined. So that's the first part of that. Next up, we want to go ahead and solve this. And I'll zoom in here. So we do have a proportion, one fraction equal to another fraction. So you might remember we can cross multiply. So negative 3 times x is equal to 3 times 10. So negative 3x equals 30, and we want to get that x by itself, so we need to divide by 3, or negative 3 rather, and x equals negative 10. Next up, consider the following equation. We're basically asked to do the same thing. State any restrictions on the variable. We do have a variable in the denominator there, so got to make sure none of these denominators are 0. So x minus 9 cannot be equal to 0. So in that case, we've got to do a little bit of algebra, so we'll just add 9 to both sides, and we get x cannot be 9. So that's not our solution, that's just what x cannot be. In step 2, solve the equation if possible. So we're going to do what we did on the previous problem. We've got one fraction equal to another fraction, so we can cross multiply. This one's going to look a little bit different when we set it up. But we've got negative 5 times negative 7 is equal to 1 times x minus 9. Okay, so we got 35 on the left equals x minus 9. Add 9 to get x by itself, and we get x equals 44. Next up, basically the same thing. Consider the following equation stating the restrictions. And again, the reminder that the denominator cannot be 0. So if we've got a variable in that denominator, we've got to make sure that x plus 8 is not equal to 0. So do a little bit of algebra to figure out what x can't be. And x cannot be negative 8. Okay, step 2, solve the equation if possible. So let's zoom in here. And it is a proportion. We've got a fraction on the left equal to a fraction on the right. So we can just cross multiply 2 times x minus 4 is equal to negative 6 times x plus 8. Okay, so we'll just continue to work this out. You can distribute the 2 to both those terms. Distribute the negative 6 to both those terms. We got 2 times x here. 2 times negative 4. Negative 6 times x. Negative 6 times 8. Then we just want to do some work to get the x's on the same side. Eight x equals negative 40 and divide. And x equals negative 5. Okay, consider the following equation. State any restriction on the variable if they exist. So here we've got x over 2 minus 2 over 5 equals 3 over 5. And like I said before, if there's a variable on the bottom in the denominator, there will be a restriction. In this case, no variables on the denominator, so no restriction. Okay, and you'll have a little button you can press to indicate that there's no restriction. Next up, solve the equation if possible. If there's a solution, express your answer as either an integer or a simplified fraction. So what we've looked at in the past were proportions. So just one fraction equal to another fraction. In this case, we've got a more complicated rational expression. We've got more than just two fractions. And you might remember the tip on that first page. If you've got a bunch of fractions, you can solve it and simplify by multiplying everything by the common denominator. So let's see here. Multiply each numerator by the common denominator. So in other words, something that all the denominators go into. So if we look at this here, we've got 2, 5, and 5 as our denominators. So our common denominator, something that both 2 and 5 go into, is 10. So what we're going to do is take each numerator times 10. And what I like to do is to simplify before I multiply. So the 10 and the 2, those both reduce to 5. 10 and the 5 in the second fraction, those both reduce, and the 10 is turned into a 2. And same with this other fraction. 10 in the 5 reduced to just 2. So now what we've got is a 5 in front of an x here for this first fraction, minus 2 times 2, which is 4, equals 2 times 3, which is 6. Okay, so all in all, a much easier problem to solve. And x equals 2. Okay, next up, negative 2x plus x plus 2 over 3 equals negative 4/3. State any restrictions on the variable if they exist. So we got a few different fractions, and let's zoom in here. The denominator of this first one is 1. So our denominators, if we look at all of them, we've got 1, we've got 3, and we've got 3. Those are all our denominators. So, and like I said on the previous problem, if there are no variables in the denominator, that means there are no restrictions. Nothing that would make these denominators 0. So here, no restriction. And then to solve the equation, it's not a proportion. If it were a proportion, we could just cross multiply to solve it. But in this case, we've got multiple fractions. We've got more than just 2. There are more terms than just 2. So we're going to want to multiply by the common denominator. And let's see. Multiply common denominator times all the numerators. And our common denominator here, if we look at, we've got 1, 3, and 3. So our common denominator hopefully is pretty easy to come up with. It's actually going to be 3. All those terms go into 3. And then if we do a little bit of reducing, 3 and the 1, nothing really happens there. It's just stays 3. But in the second fraction, the 3 and the 3 reduce to 1. In other words, they cancel each other out. And then the same on this third fraction. So here we've got negative 6x over 1, which is just negative 6x. And then for our second one, we've gotten rid of our 3's, and we're just left with x plus 2. And then our 3's have disappeared on that last fraction. And we're just left with negative 4. So now we've got some like terms we can put together. Negative 6x and x is negative 5x. Negative 4 and negative 2 is negative 6. And then divide by negative 5. And we've got x equals negative 6 over negative 5, or x equals 6 over 5. Anytime you've got a negative over a negative, they just become positive. Next up, 6 over 7x minus 5 over 7 equals 4 over x. We do have some variables in the denominator, so that means we will have a restriction. So for step 1, state any restriction on the variable if they exist. So here, 7x cannot be equal to 0. And then also x cannot be equal to 0. So there we've got one restriction. On the left, we've got to divide by 7 to figure out what x can't be. And x cannot be 0 divided by 7 is just 0. So in other words, we've got x cannot be 0 and x cannot be 0. You wouldn't necessarily put in both those answers since they're the same thing. You just put in one. Next up, if we're going to solve this rational expression, can't do cross multiplying because we've got too many fractions, but we can multiply the common denominator, which in this case, one of our denominators is 7x, one of our denominators is 7, and the other denominator is x. So our common denominator actually, well, between the numbers we know is 7, but we've also got to make sure that these x's are a part of our common denominator. So our common denominator is going to be 7x, and we're going to take that times every one of those numerators. So for this first one, the 7x's cancel each other out. 7 on top and 7 on bottom disappear. So do the x's. For the second term, the 7 on top and the 7 on bottom cancel. And for the third term, the x and the x cancel out. So for that first one, all we're left with is just the 6 minus. For the second one, we're just left with x times 5. And then for the last one, we're left with 7 times 4. (28 minus 6, 22). Divide -5. We get x equals 22 over -5. Or you could put the minus on top or in the middle. -22 over 5. Okay, next up, consider the following equation. 2 over x plus 2 equals 1 minus 4 over x plus 6. State any restrictions on the variable if they exist. Again, remember, x plus 2 cannot be 0. So we'll have to do a little bit of math on that. And then also, x plus 6 cannot be 0. So x cannot be -2. And x cannot be -6. Okay. Then as far as solving this, not a proportion, so we'll have to try that shortcut method that we used. And one thing that may take a few practice problems to get used to is coming up with a common denominator for a problem like this, where we've got x plus 2 on bottom, we've got x plus 6 on bottom. Common denominator is actually fairly simple to come up with. You're just basically going to use both of those factors. So we're going to take 2 times x plus 2, and then also x plus 6. And then that's going to be our common denominator that we take times every single one of those terms. So 1 times x plus 2, x plus 6, and then 4 times x plus 2, x plus 6. Okay, and the nice thing that happens here is the x plus 2's cancel in the first fraction. And then we're just left with that. Nothing cancels with the 1, but the x plus 6's cancel in that last fraction. Okay, so now we've got 2 times x plus 6 equals 1 times anything is just that thing, so we could go ahead and leave the 1 off. X plus 2 times x plus 6 minus 4 times x plus 2. Okay, so we could distribute 2 times x, 2 times 6, and we get 2x plus 12 equals, and on the right side we can distribute this x to both of those terms, and then we'll also have to distribute the 2. X times x is x squared, x times 6, 6x, 2 times x is 2x, and then 2 times 6 is 12. And then we've got a little bit more to add to it because we've got to distribute, let's go back. Got to distribute this negative 4 to both the x and the 2. Make sure you distribute negative 4 and not just 4. So negative 4 times x is negative 4x, and negative 4 times 2 is negative 8. Okay, so on the right side we've got some like terms that we can put together. We've got 6x, 2x, and negative 4x. We've also got 12 and negative 8 that we can put together. So 6x and 2x is 8x, minus 4x is 4x, and then 12 minus 8 is positive 4. And one thing we talked about in the last section was solving these types of problems. It is a quadratic equation. So we want to set it equal to 0 and then also factor. So in order to set it equal to 0, what we want to do is move the terms from the left to the right side. So to set it equal to 0, I want to subtract 2x. That'll move that over. So I'll put subtract 2x under the 4x. And then also I want to turn the 12 into 0, so I'll subtract 0, or subtract 12 rather, from both sides. Now we've got 0 on the left. And then x squared plus 2x minus 8 on the right. So we did the set equal to 0 part. Now we need to factor. Trinomials are going to factor into 2 parentheses. The first 2 things have to multiply to be x squared. That's usually pretty simple. Then we're looking for 2 factors of 8, negative 8, that multiply to be, or that add to be 2. Four and 2 could add to be 2, and we want them to be positive. So positive 4 and negative 2. Then we just want to solve this. Anytime you've got the 2 parentheses equal to 0, one of those 2 needs to be 0. So x plus 4 equals 0, or x minus 2 equals 0. Okay, and one thing you'll want to do on just about all these problems, you will want to look back and compare your restrictions with your answers. So here we had, let's look at these earlier ones. Here we had x couldn't be these things. X couldn't be -2 and -6. As long as our answers down here are not -2 or -6, then they both check out. They're okay. And lastly, this is probably the most complicated problem that you'll see in 11.4. X over x plus 4 equals 1 over x plus 1 minus 3x over x squared plus 5x plus 4. So you could say x plus 4. That denominator can't be 0. X plus 1 can't be 0. And we could also say that x squared plus 5x plus 4 can't be 0. Although the way they work these out, they're actually pretty nice. Let me zoom in here for a second. This x squared plus 5x plus 4 would factor into x plus 4 and x plus 1. And you might notice those are our same denominators that we had here and here. So whatever restrictions we have for those first two fractions will also apply there and there. So subtract 4 and x cannot be -4. Subtract 1 and x cannot be -1. Okay, and then solving this, we need a common denominator. Our common denominator is actually going to be those same denominators, x plus 4 and then x minus 4. Or not minus 1, x plus 1. Let's erase this. X plus 4 and x plus 1. So we're going to take that common denominator times every single one of those terms. Okay, and then the nice thing about this is you have some things that cancel. So in this first fraction, the x plus 4's disappear. And we're just left with x and x plus 1 on top. In the second one, the x plus 1's disappear. And in the third fraction, this is factored, that trinomial is factored, so it just becomes those two factors. And the x plus 4 and the x plus 4, x plus 1 cancel out. And ultimately, we're left with x and x plus 1 in this first fraction equals 1 times x plus 4. And again, 1 times anything is just that thing. So 1 times x plus 4 is x plus 4. Minus, we just had 3x in that last fraction. Okay, so now we just do what we would typically do, distribute. So we've got x squared plus x, or 1x, equals, on the other side, we've got some like terms we can put together. X and negative 3x is negative 2x plus 4. And at this point, we've got a quadratic equation. So we want to set equal to 0 and factor. So we're going to move everything to that side. So we're going to add 2x. And then we're also going to subtract 4. So on the right now we've got 0. On the left we've got x squared plus, when we add the x's, we've got 3x minus 4. Then we want to factor that. It's going to factor into 2 parentheses equal to 0. So we've got an x and an x. And then we want some factors of negative 4 that add to be 3. So 4 might work, and 1. And we want them to add to be positive 3. So we need the 4 to be positive and the 1 to be negative. One of those 2 parentheses has to be 0, so we'll just set that up and solve it. Okay, and before we call it good and enter those answers in, you will want to take a second and look back at our restrictions. Up here, we've got x can't be negative 4 and x can't be negative 1. But we do have x equals negative 4. That is a restriction. In other words, if we put negative 4 back in, say, the first fraction, for instance, that would make the denominator 0, would make the fraction undefined, and it would make the whole equation undefined. So for this restriction, we'll just put a line through that. We're not going to enter that answer in. And this x equals 1 part, that's the only answer we enter. Okay? And that's section 11.4.